Welcome back to the video series on integration and differential equations. Today we're going to take a look at double integration. Here's our example. We would like to evaluate the following double integral. So the way double integration works is we're going to start with the inside integral. We'll do the inside integral first, and if we look at that inside integral, notice that there's a dy in that integral. So dy is telling us that we're going to integrate with respect to y. As we integrate with respect to y, we're going to treat x as a constant. So let's try our first step of the calculation. Since we're working with the inside integral, the outside integral is not going to be changing. I'm going to recopy that integral from 1 to 2. I'm also going to recopy the dx at the back there, and all our work is going to take place inside that integral. Okay, so let's focus on our inside integral here. We are integrating with respect to y, so y squared is going to integrate to y cubed over 3. As we go on to the second term, we're going to treat x just like any other coefficient. So we would keep that in place, and the y cubed would integrate to y to the 4th over 4. So we've integrated, now we need to evaluate. And since y was the variable that we were integrating, y is the variable that we're going to be subbing into. So we're going to evaluate at y equal x, and then we're going to evaluate at y equals 0. And those quantities there are coming from the limits on the inside integral. Okay, so let's try our evaluation step. We're going to keep that outside integral on there, we're going to keep the dx on there, and we're just going to work inside that integral. Okay, so let's start by subbing in y equal x. As we sub in, we'd get x cubed over 3 plus, subbing in y equal x into the second term, well, we'd have x to the 4th times another copy of x. So x to the 5th over 4. And then we need to subtract off what happens when we plug in y equals 0. Both those terms would become 0. So I'm just going to write minus 0. So next thing I would do is just clean up the integrand. We're going to keep the outside integral on there. We're going to keep the dx on there. But let's just clean up what's in those brackets. X cubed over 3 plus x to the 5th over 4 is now a simpler way of writing that integrand. So at this point, I'm going to write down a big happy face because we've now reduced the problem to a familiar single variable integration. So this is just like a regular integration from way back when we first saw how to integrate. So we've reduced that double integral now. All right, so let's do a couple more steps here. We will now integrate with respect to x. Remember, the differential at the back here is always reminding us what variable we're integrating with respect to. So integrating with respect to x, we'd have x to the 4th over 12 plus x to the 6th over 24, and we'll evaluate at 2 and then at 1. So plugging in the x value 2, we get 16 over 12 plus 64 over 24, and then we're going to subtract off what we get at x equal 1. So 1/12 plus 1 over 24. Okay, if we were to put everything over 24, this would work out to 93 over 24. So that's one way to give your answer, or you could reduce that fraction and call it 31 over 8. So that was our first example of double integration. Thanks for watching, and we'll see you in the next video.